Okay, guys, so yesterday we started talking about inequalities. We have already gone over your homework, okay? And today we're going to be learning how to solve one-step inequalities, okay? So now we're going to, yesterday we kind of input numbers in for our variables, but now we're going to actually find out what that variable can be, okay? With an additional step. Okay, so let's just go back over what we learned yesterday. We have 4 inequality signs. Greater than, how would we write greater than? Which way is our alligator mouth going to be opening? To the right or to the left?
The left.
The left. The left, absolutely. So greater than, okay. Which way is our alligator mouth going to be opening for less than?
Right.
To the right. Absolutely. Okay. Now we have greater than or equal to, and this was the new sign that we learned. How do we write greater than or equal to?
With the mouth open to the left quadrant.
Absolutely. So our mouth is still open to the left, but now we have half of our equal sign. And that means equal to. And how do we write less than or equal to?
To the right of the line.
Absolutely. So it's still open to the right, but now we have half of our equal sign directly below it. And that means that the x could be equal or greater or less than. Okay, so when we're talking about solving one-step equations, guys, this is exactly the same way. I know, well, okay, so we're solving one-step inequalities, but it is almost exactly the same way as doing equations, okay? And we have previously talked about doing one-step equations. And keep in mind that whenever we are solving for x, think of it as like a puzzle, okay? We're going to take it apart slowly, step by step, and we're going to work our way. We're going to start at the bottom of our PIMDAs, at the bottom of our order of operations. Because see, now we're not coming up with an answer for the end. We're not finding a solution for our end. We're actually solving for part of it. So instead of working down from the top with parentheses, exponents, multiplication and division, addition and subtraction, now we're going to work from the bottom. So here we have, and we're going to start at the bottom and we're going to work up. Okay? Yeah. Because see, here we're taking it apart. We're trying to isolate our variable. Isolate, which also means get it all alone. Okay? So looking at x plus 4 is greater than 7. Okay? So you start from the bottom and you say, well, do we have anything that is being added or subtracted to that variable? What is happening to that variable?
X is being added to 4.
Okay, we have 4 being added to x. Perfect. Now, keep in mind, remember our scale? Okay? If we're going to do something to one side, we're going to add or subtract. We can't leave it out of balance, right? Straighten me up. So then we have to, do it to the other side as well. So to get rid of this plus 4 or this positive 4, how do we get rid of it? What do we need to do?
Add a negative 4.
Subtract 4 or add a negative 4. I like how you said that. So we're going to say minus 4. And once again, just like an equation, I have to keep everything in balance. So I just subtracted 4 on that side. So now I'm out of balance. So what do I have to do? Subtract 4 to the other side. Okay? So my positive 4 and my negative 4, they cancel out because they become 0. It would be plus 0. That leaves us with just x. We bring our inequality sign straight down, just like we do whenever we are adding or subtracting and we have our equation, our equal sign. And then we have 7 minus 4. So what is 7 minus 4?
3.
Positive 3. Absolutely. So now our answer is x is greater than 3. Huh. So does that mean that x can be 4?
Yes.
Does that mean x can be 10?
Yes.
Does that mean x can be 20?
Yes.
Let's double check it. Let's find any number that's greater than 3. Let's do 4, and we're going to plug it in here. If I say, well, I'm going to choose 4 because x is any number greater than 4, I'm going to say, well, 4 plus 4, and I'm just going to rewrite it, is greater than 7. What's 4 plus 4?
8.
And is 8 indeed greater than 7?
Yes.
So my answer works. X is any number greater than 3. Now, what would have happened if I would have checked my work with the number 3? Yes, exactly. It wouldn't work because then I would have gotten 7 is greater than 7. And is that a true statement? No. Okay. Looking at the one right below or right beside it, here we have x minus 6 is less than 9. So thinking about our order of operations, we're going to start at the bottom and we're going to say, is there any addition or subtraction?
Yes.
Yes. What is happening right here? But what is our operation that we are doing? Okay, because we are subtracting 6, so we have to cancel that out. What's the opposite of subtraction? Or we have a negative 6, how do we cancel that out? By adding 6. Very good. And what we do to one side, we say it out louder. What we do to one side, we
Plus 2 to the other.
So we're going to add 6. My negative 6 and my positive 6 cancel. I am left, my x falls down, my inequality sign falls straight down. And what is 9 plus 6?
15.
15. So now I have x is any number less than 15. Let's check it. Give me a number less than 15. 3. Okay, perfect. Let's check it. So I'm going to plug 3 in here. 3 minus 6 is less than 9. Ooh, she got us a good negative number. Okay, what is 3 minus 6? Negative 3. And is negative 3 less than 9?
Yeah.
So that absolutely works. So x is any number less than 15. Okay, moving on to the next one. Oh, sorry. Okay, here we have 2x is less than or equal to 12. Ooh. First off, we're going to start at the bottom of our PIMDAs, the bottom of our order of operations. Do we have any addition or subtraction happening? No. Now go to the next one. Do we have any multiplication or division happening? Division or dividing? We are multiplying, but what is the opposite of multiplication? Division. So that's how we get rid of that. So we're going to say 2x and we're going to divide that by 2. What we do to one side, we. So now my 2's cancel out because they become 1. 2 divided by 2 is 1. 1x. We don't have to write that 1, right? So our x falls down. Our inequality sign falls down. Now what is 12 divided by 2? Anyone?
6.
So now we have x is less than or equal to 6. How can we check this?
Any number less than 6.
Any number less than 6? Give me one. 4. Okay, let's check it. I'm going to erase this real quick. Okay. You said 4, so I'm going to plug this in here. I'm going to say 4 times 2. Sorry, I should have said 2 times 4. It's the same thing, right? Is less than or equal to 12. What is 4 times 2? 8. And is 8 less than or equal to 12?
Yes.
It is. Now, what else should I check on this real quick? If it's equal. Yeah. So can I use the number 6? Can I check with the number 6?
Yes.
So I'm going to go ahead and I'm going to say 2 times 6, plug 6 in, should be less than or equal to 12. What's 2 times 6?
12.
And is 12 less than or equal to 12?
Yes.
Absolutely. So both of these solutions work, so I know that my statement is correct. Okay? Looking at the next one, we have x over 5 is greater than 1. Am I doing any addition or subtraction? No. Am I doing any multiplication or division?
Yes.
Yes. What is happening? What is happening? Okay, division, so we need to multiply. Not cross multiplication, just multiply. Okay, so I am dividing x by 5, so I need to multiply by 5. Perfect.
Did you do the reciprocal?
Isn't that the reciprocal, 5 over 1? Because this is 1x over 5. Do you see that? Okay, so I'm going to multiply by 5. What I do to one side, good job. My 5's cancel out, and I am left with x. And I'm going to drop my sign right down. And what is 1 times 5? 5. So I can check this by saying x is greater than 5. So what number could I use to check this?
10.
10. I love that you picked 10. You're thinking ahead, aren't you?
Sure.
Okay. Let's do 10. So we're going to plug 10 in for x. 10 divided by 5, and that should be greater than 1. What is 10 divided by 5? 2. And is 2 greater than 1?
Yes.
Absolutely. So our answer, our solution checks out. Okay? Okay, so I am going to give you a few minutes to do numbers 1 through 6. Okay, I'm going to give you about 5 minutes, and then we're going to check our answers real quick. Okay, so looking at number 1, solve the following. X plus 6 is less than 13. What did you do?
I put -6 underneath 5.6.
Okay,
And
those two canceled out, then what?
And I had -6 for 13.
Perfect.
Got 7.
Okay,
And drop the x down.
okay.
And the less than sign.
So I have x is less than 7. Thumbs up or thumbs down? Let me see. 6 plus 6? It's 12. Is 12 less than 13? Absolutely. Now, for my answer, can I just put 7 in there?
No.
No, exactly. I have to write the entire thing because x is less than 7 means that it's not 7, that it's any number less than 7. So I do have to write the entire thing. That way it shows that it can be the number 6, it can be the number 5, it can be the number 4, okay, because it's any number less than 7. Okay, going right down below, number 2, solve the following. X minus 3 is greater than or equal to 21. What did you do?
So I canceled out the -3 by putting a positive 3, and then added 3 to 21, and then brought my greater than and equal to sign. So I got x is greater than or equal to 24.
Perfect. X is greater than or equal to 24. Thumbs up or thumbs down? You got it?
I got it, but I forgot. I accidentally left it.
Oh, you didn't balance it, did you? Yeah, you got to balance it. And then we can check that and see if you had checked your answer, it would not have come out because you would have had 21 minus 3, which would have been 18. And is 18 greater than or equal to 21?
Yeah, I checked my answer wrong, and that's why I thought I got it right, because I checked my answer wrong.
You can check your answer wrong too. Okay, so x is greater than or equal to 24, and if we plug that in there, we would get 24 minus 3. And what is 24 minus 3? 21, so that would be equal. Those would check. We could also check any number greater than 24, so like 25. And 25 minus 3 is going to be
22.
22, and 22 is indeed greater than 21. So our answer is x is greater than or equal to 24. I have to include the entire thing. Okay, so now looking at number 3, solve for the following. For x is greater than 24, what should we do here for number 3?
So, 4 divided by 4, and I'll cancel it out.
Okay,
And then what you do once I get to together, so 4 divided by 4.
perfect.
Drop down the x, and
Yeah.
that's fine. And then 24 divided by 4 is 6.
Exactly. Thumbs up or thumbs down? Did everybody get that x is greater than 6?
I think that I accidentally put 4 instead of 6.
Oh my goodness. You're going too fast. Okay, so any number greater than 6, give me a number greater than 6. Any number? 92. I don't want to multiply 92 by 4 right now.
10.
4 times 92 is greater than 24. 4 times 2 is 8. 4 times 9 is 36. Is 368 indeed greater than 24?
Yes.
Yes.
Really close.
So my answer is x is greater than 6.
Good.
It's a good thing your teacher can kind of multiply in her head real fast.
That was also exactly correct.
Okay, number 4. Number 4. X divided by 3 is less than or equal to 9. What did you do?
I did the reciprocal, so 3 over 1 times x over 3.
Exactly. We multiply by the reciprocal, 3 over 1.
The 3's cancel out, and then you have to multiply them by 3.
Okay.
X times 3 is 27, and we drop the x in it.
So now we have x is less than or equal to 27. So I can check this. I can plug in 27 over 3. Should be less than or equal to 9. What's 27 divided by 3?
Good.
9, and is 9 less than or equal to 9?
Yes.
Okay. I could check, what's a number less than 27?
21.
21. 21 over 3 should be less than or equal to 9. What's 21 divided by 3?
7.
7. Is 7 less than or equal to 9?
Yes.
So my answer is x is less than or equal to 27. Perfect. Number 5 might have been a little tricky. Number 5 might have been a little tricky. What did you do here?
10 divided by 10.
Okay.
Do it to the other side of the here.
Absolutely.
And then bring down x or equal
Okay. Now, we can have 0 as an answer?
Yes, because we can have negative numbers, which are less.
Absolutely, because we can have negative numbers. So here, x is greater than or equal to 0. Okay? So what is a number greater than 0?
0.1.
0.1. Absolutely. Okay? Or 2.
45.
Let's do 2.
9 billion, 4 billion,
10 times 2 is 20, and that is indeed greater than 0. Could I input 0 in there? What's 10 times 0?
0.
And is 0 greater than or equal to 0?
Yes.
Yes. So my answer is x is greater than or equal to 0. Absolutely. Okay. Looking at number 6, the very last one. What do I need to do?
You need to multiply x over 11 with reciprocal.
Okay, and what's its reciprocal?
11 over 1.
Perfect.
And then those cancel out. And then you do 2 times 11, and that gives you 22. And then you drop your x and you're less than sign.
Perfect. X is less than 22. Yes, sir.
Never mind.
Okay. Oh, yeah. Give me thumbs up or thumbs down. X is less than 22. Can I input 22 here to check my answer?
No.
No. Why?
Because it's not equal to.
It is not equal to. Very good. Okay, so x is less than 22. I could put in 20. Okay. 20 over 11 should be less than 2. And how many times can 11 go into 20? 1. So that would be a big 1, and that would leave us with 9 over 11. And is 1 and 9 11ths less than 2?
Yes.
Yes. So our answer is correct. X is less than 22. Do you guys have any questions?